This is question 1 of the AQA June 2014 Unit 1 Physics paper. In this question, you're asked to give one advantage and one disadvantage of using nuclear power stations rather than gas-fired power stations to generate electricity. The main advantage of using nuclear power stations is that they produce very little CO2. And so that's the first mark. I think that's the most obvious reason why you would want to use a nuclear power station. So they produce little CO2. There are advantages which we'll go into later, but I think for me going forward that would be the most obvious answer to choose when talking about nuclear power stations. The most obvious disadvantage of nuclear power stations is that they produce radioactive waste. So again, with this question, I think that's the answer that comes to mind most easily, and probably the one you should learn about a disadvantage about nuclear power stations is that they produce nuclear or radioactive waste. And now what we'll do is we'll move on to the next part of this question. Just to look over now some of the other answers we could have had for question 1 part A. You can see on screen now that this is really what I was talking about, with the idea that they produce little CO2 or greenhouse gas or carbon dioxide. The other option that you could have comparing nuclear fuel and nuclear power stations to most other power stations is they've got a very high energy density in fuel, which basically means that for a smaller mass of nuclear fuel such as uranium or plutonium, you can create more energy from that and more electricity. And the final part of this question is that they've got a longer operating life. So the idea that nuclear power stations will last longer than fossil fuels or gas power stations, and it also allows us to save using the reserves of fossil fuel power stations as well. Now let's just have a quick look at the other options for the disadvantages of using nuclear power stations compared to gas power stations. Again, you can see at the top here that they produce long-term radioactive waste is the one that I said that was probably the easiest one to remember, and you can remember to have nuclear or radioactive there. The other options that you've got is your accidents at nuclear power stations may have far-reaching or long-term consequences. You could also here add in things like Fukushima or Chernobyl, and in this next one you could have had the idea that it costs a lot more to decommission and also build the nuclear power stations because of the radioactive element to them as well. There's more safety procedures and they just take a bit more building. And finally, they've got longer startup times compared to gas power stations. I think nuclear power is probably quicker than coal, but they've got longer startup times than gas. Moving on to question 1 part B, we've got a calculation question here. So it says a single wind turbine has a maximum power output of 2000 watts, and the wind turbine operated continuously at maximum power for 6 hours, which highlighting those there. So what we've got there is we've got a power, and we also know that 6 hours of time. So what we want to do now is we want to look at the formula sheet to try and find an equation that involves power and time, and we should find out that E for energy equals power times time. And that's good because we wanted to work out the energy output. So have a very quick look here. We want our energy output to be in kilowatt hours. So we can see that our time, as I've already circled up here, is in hours. That's fine. But our power is in watts, and we've got 2 million watts there. So we need to be able to convert the watts into kilowatts first. Now, if this was a question, and you've got this information here, you'd automatically get 1 mark for just substituting those two numbers into the equation. So you're not sure what else to do, just put the numbers in and you've at least got yourself 1 mark. Personally, I'm going to convert my my power first. So I've got 2 million watts. I know that's equal to 2 million divided by 1000, which gives me 2000 kilowatts. Okay, I'm just going to move this on to the next slide now, so I've got a bit more room to do the rest of the working. So from the last time we had the idea that energy is equal to power times time. We also know that power is 2000 kilowatts and that time was 6 hours. I got those from the question. So you can just put those numbers in now to get energy equals 2,000 multiplied by 6. And we know that's going to equal 12,000 kilowatts hours. And that there will get us 2 marks for 12,000 kilowatt hours. But if we just put the numbers into the equation, that would also get us 1 mark. The next part of the question is saying, why on average do wind turbines operate at maximum power output only 30% of the time? Well, what they're trying to get you to write there is the idea, or get across the idea, that wind turbines are unreliable. They're unreliable because it's not always windy, and therefore they won't always be working. And also there's variations in the fluctuations of the wind, so sometimes the wind's very strong, sometimes it's not so strong, and that changes the amount of output you can get from the wind turbine. You also could get marks for saying that the wind turbines aren't turned on when it's extremely windy as well. What I'm going to do is I'm going to pop up on the next slide the actual mark scheme so you can see the different parts and how you could have got the marks in different ways. So here are the different ways you could have got the mark for question 1 part B part II, and that is any of the following. So you could have had the idea that wind is unreliable, as I've mentioned on the other side, the idea that you shut down if the wind is too strong or too weak, and finally the wind is variable. So any ideas or words to that effect that represent those 3 key ideas, you've been able to pick up the mark in that question. So the last part of the question says, an onshore wind farm is made up of many individual wind turbines. They connect to the national grid using underground power cables. I want you to give one advantage of using underground power cables rather than overhead power cables. Now this one you've got plenty of options. You've got the idea that by being underground they're out of the way, so they're less of an eyesore, so they can't be seen by other people. You've got the other option, that the idea that they're under the ground, they're less likely to be damaged by things such as storms or wind. And also you've got the idea that it's actually safer to have them underground because they're less likely to come in contact with people and therefore give people electrocution. Now, let me just try and grab these up from the bottom there. There we are. These are the ones you've got in there. So you, as I said before, you can't be seen. Comes top. No hazards to low-flying helicopters, unlikely to be damaged or affected by severe weather, and there's no need to reduce shock hazard from them either, which you would have to do with overhead ones. And that brings us to the end of the question.